In this lesson, we will find zeros of a polynomial function, use the linear factorization to find polynomials with given zeros. In this example, we're asked to find a function f defined by a polynomial of degree 3 that satisfies the given conditions. So here's the conditions. That it will have three zeros of -1, 2, and 4, and that when you evaluate it, f of 1, that it will equal 3. So the first thing we're going to do here is write out as much information as we know for this polynomial function. So we're told that it's a degree 3 and that the three factors, which we already have them, so we don't have to go looking for them, or we don't have to plug them into the synthetic division. If one of the zero is -1, so recall to write it as a factor, it has to be in the form of x minus k. So being that it's a negative, x minus -1 would be x plus -1. So recall it's always the opposite. So our first factor is going to be x plus 1. The next one is x minus 2. And then the last one, if you guessed it, yes, x minus 4. Okay? So recall that the number of zeros theorem state that whatever the highest degree of the polynomial is, that is at most the amount of distinct zeros that you'll have. So again, we were told that it had a degree of 3, so that's how we knew that it has 3 zeros. And here's the 3 zeros that we were given. So again, we know that it's going to have 3 zeros and 3 linear factors. And the only thing we need to know now at this point to finish writing this polynomial, because that's what they're asking us to do here, is just simply to write the function. So here's what we know. As I just stated, with the three factors, that's how you write it in the x minus k form. What we don't know is the coefficient here, the leading coefficient, whether the function is going to be facing upward or downward, being that it's a negative or a positive. So what you're going to do is you're going to plug into values that you know. So if we're given, here's our x and y. Remember, for a function, your input is your x. So x is 1. And your output is always y, and y is 3. So into this function we have so far, you know that f of x is the same thing as y. So here we're going to remove f of x and replace it with 3, our y value. And then our x value here is 1 because the input is 1. So we're going to remove x and replace it with a 1. So when we plug in those values, it's going to look like so. So notice everywhere you saw an x, we replaced it with 1 because that's the given x value. And everywhere we saw y, which f of x is y, we're going to replace a 3 again. That was the given y value. So when we do the math on that, for the first group here, know that 1 plus 1 is 2. Combine the inside of the second parentheses, you get -1. Combine the inside of the third parentheses, you get -3. Multiply those together, and what you get is 6a on the right side and 3 on the left side. Last step to solving for a is to divide by 6. Recall, whatever you do to one side, you must also do to the other. When you simplify it, you will see that a equals 1/2. So now we have everything that we need to put together this polynomial function of third degree. So when we plug in a, this is our polynomial function in linear factorization form. And there you have it in that. Now that we have it in linear factorization form, our next step is we're going to write it in standard form. And so to write it in standard form, what you're going to have to do is multiply these factors. Now you have those three factors in parentheses, and the easiest way to multiply those would be to take any two and use FOIL, first, outer, inner, last. Remember, FOIL is you use that when you want to multiply two binomials. So let's just say we take the first group there of the two binomials and multiply them. That's going to leave us with x squared minus x minus 2. And from there, you're going to multiply a binomial by a trinomial and multiply that. So remember, you're going to have to distribute x to all three terms in the trinomial. And then you're also going to have to distribute a -4 to all three terms in the trinomial. So when we do so, it's going to look like so. Last step now is that we're going to distribute the 1/2 because it's outside, so we must distribute that 1/2 to every term within the parentheses. So when we do so, it's going to look like so. Simplify everything that can be simplified, and we are left with our polynomial in standard form, which is f of x equals 1/2 x to the third power minus 5/2 x squared plus x plus 4. And there you have it. In this example, we're asked to find a function f defined by a polynomial of third degree that satisfies the given conditions. Here's the conditions. That -2 is a 0 of multiplicity 3. Also, that f of -1 has to equal 4. So what we're doing here in this problem is just simply writing a function, a polynomial function. So we're told that it has a degree of 3, so we know that it's going to have 3 zeros and 3 linear factors. In other words, 3 of those x minus this, or x minus that, or x plus this. So 3 of those. So you say, okay, well, how am I going to have 3 of those when I'm only given that -2 is a 0? Well, here's that other important information in the back of it. They told you that it is a 0 of multiplicity 3. And what that means, multiplicity 3, is that it occurs 3 times. So in other words, if you were to write it as linear factorization, it's the same as having, and we know we do the opposite here because this is -2. So when we write it as x minus k, it's going to wind up being x plus 2. So if we write it in linear factorization form, it would be x plus 2 times x plus 2 times x plus 2. 3 times, 3 of those. But instead of writing it that way, we can write it the shorthand way and just write it once and just put a little 3 up in the upper right hand corner as its exponent, meaning that it occurs 3 times. So all we need to do then is just simply define a, and to do that, we're going to plug in our given values for x and y. We were given a -1 for x, and we were given a 4 for y. So by determining what a is, we'll know what the end behavior of that graph would be. In other words, is the leading coefficient, is it a negative or is it a positive? So let's go ahead and plug in those values that we're given. So remove x and replace it with -1. Remove y and replace with 4. We want to solve for a. So within the parentheses, that's going to equal 1. And 1 multiplied 3 times is still going to be 1. And here we see that a equals 4. So when you put everything together and write your equation, what you're going to have is, all right, so I apologize for that phone call there, but yes, what you'll have is 4 times x plus 2 raised to the third power, and that is your polynomial function. Now we want to write it in standard form. So if we write it in standard form, we're going to have to expand this. So remember, we have 3 of the x plus 2's. So let's go ahead and write that out. The next thing you're going to do is, like I said before of the previous problem, we can just take 2 of them and use FOIL, first, outer, inner, last, 2 of the binomials, 2 at a time. There you go. That's going to give us a trinomial, and then you're going to multiply the binomial with the trinomial. So let's go ahead and do that. Lastly, you're going to distribute the 4, multiply the 4 by all the terms that are in the parentheses. And once you do that, you have your answer in standard form. There you have your given equation, f of x equals 4x cubed plus 24x squared plus 48x plus 32. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.